Sample problem 10.15. Large hyperbaric chambers are used mainly to treat victims of diving accidents. In one treatment protocol at a typical facility, the chamber is pressurized to 6 atmospheres, 6.0 atmospheres with compressed air, and the patient breathes a mixture of gases that's 47% O2 by volume. In another protocol, the chamber is pressurized with compressed air to 2.8 atmospheres, and the patient breathes pure O2. Determine the partial pressure of O2 in each treatment protocol and compare the results. Okay, so the idea here is the partial pressure of oxygen is equal to the mole fraction of oxygen times the total pressure. Okay, that's the expression we would use. So in the first case, they tell us it's 47% O2 by volume. Well, the volume of the gas is proportional to the number of moles. So the mole fraction is proportional to the ratio of the volumes. So if it's 47% O2 by volume, that means the moles of O2 divided by the total number of moles is 47 out of 100, 47%. So that would be 47 out of 100, that's your mole fraction. And then they tell you that the total pressure is 6 atmospheres. Okay? In the second treatment, they tell you it's pure oxygen. That means the mole fraction is 1. Right? And so if the mole fraction is 1, and then they tell you that the total pressure, or the pressure, is 2.8 atmospheres, that would give you the pressure of O2 in that example. So now, in part A, we would have 0.47 times 6.0 is 2.82. And then in the second one, 1 times 2.8 is 2.8. So it looks like it's about the same, right? So there you go. So it turns out the comparison shows that in both cases, the partial pressure is about the same. It's about 2.8 atmospheres.